This right here is the hot end from a 3D printer. This is the nozzle where the plastic is extruded from. Now this is a 0.4 millimeter nozzle, a fairly standard size. You can get finer ones or you can get thicker ones, but this one's pretty standard. That 0.4 millimeters is important because it affects how fine of a detail you can print. Here's another one of my test print pieces. I've got a whole bunch of narrow gouges and raised features. This is to test the fine printing of my printers, and it lists how big each is. So over here, this narrow trough is 0.4 millimeters wide, and this shape that didn't even print out would have been 0.4 millimeters wide. This is 0.8, 1 millimeter, 1.2 millimeters, and 2 millimeters. This is important because each of these lines is a multiple, these two are multiples of line thickness. Now it's important to keep in mind your nozzle thickness because this is 0.4 millimeters, it's going to print it in one pass. In fact, if it was 0.4, if it was less than 0.4 millimeters, the printer wouldn't have a hope of being able to print it because it can't print anything thinner or smaller than the nozzle. In fact, here's a case where this thin-walled feature didn't even get picked up by the slicing program. It didn't print it at all. This 0.8 millimeters, this would have been printed with 2 passes of the nozzle, and it handled it just fine. The 1 millimeter would have done 1 pass on each side and then filled in the center. And as we get into these thicker features, it's not a problem at all. If you will notice that this trough, it handled it just fine at 0.4 millimeters, even though it never did pick up the raised features. So keep that in mind. You can print a narrower trough than you can print a raised feature. Let's talk about tall, thin prints. Tall, thin prints can give a 3D printer problems. So here's one. Notice down here, everything is printing fine. But as we get up closer to that top, it gets wobbly. Those layers didn't come through very clear. You can see nice, clean, neat layers until it gets right there. That is because of the way a 3D printer heats up plastic to 210 degrees Celsius and then lays it down. So down here, when it prints a layer, by the time it comes back to the same spot on the layer again, on the next layer above it, the plastic's had enough time to cool that it's gotten hard enough that it's not going to cause a problem. Up here, because these features are so small, by the time a printer finishes one layer and comes back to the next layer on top, the plastic below it hasn't finished hardening. It's still liquid. It's squishy. So as a result, when it puts more plastic on top, it's not a stable surface. It's like trying to build a tower out of icing. And you can see it's got those wobbles and those layers. Here's another one. Here's a 3 millimeter rod, a pin. That printed horribly. This is a failed print in my books. You can see how it just got soft and groovely. You can print it more like this if you use a couple of tricks. So here, let's take a look. Here's another one that I printed using a couple of tricks. And while it's not perfect, you can see that tip actually turned out pretty good. So here's the trick. I actually printed 2 of these, one on each opposite corner of the build plate. When it printed one layer on here, then it had to go all the way to the far side to print a layer on this one. And then it would come back and print another layer and travel back and forth. Every time it had to travel back and forth, it gave the plastic enough time to cool. Now you see I had some retraction issues, but these little grooblies, these little hairs, these clean off very easily. That's not really a problem because this one, which I've already cleared off, you can see is actually quite clean. Here's a maker's coin that one of my students printed. he put some lettering in there. Now you'll notice that there's a couple of flaws in here. That's not a problem with his model. That is because this lettering is too small for the slicing program and the printer to handle. Notice there's a gap right there. Didn't even notice the wall right there. In places like right there, it didn't really know how to fill in that space because it's too small. A few more around that eye. Now this is legible, you can read it, but if you wanted it to turn out nice, you should print it larger. In fact, we had to enlarge this coin to get that lettering to print out nicely. If you look on the back, this lettering is done bigger, but it's on the back. So because it's on the back, you get that smushing out. You can even see that edge is smushed right out. And it marred the lettering, so it's not quite as clear as it was before. Here's another example of a challenge coin. This was a beautiful model on the computer screen. There's a horse here with a mane and a tail, and it's flowing in the wind. But the details were too small for the 3D printer to print. And as a result, they didn't come through nearly as nice. In fact, same thing, you got some surface groobles where the slicing program couldn't quite handle those details and got a little confused. You'll notice these shapes on the side. Now in the model, those were square. They had sharp edges, and here they came out rounded. Now this is about as small as I think it can handle the detail. These are not so small that they're weak and they're going to break off, but they're not as sharp as they were in the computer model. So all in all, this was a nice design, but it was just a little too small for the printer to handle. Let's talk about how you should orient your print on your print bed if you want to preserve fine details. We talked about which way you should lay it out for directions of strength. We talked about which directions to produce the best curves. Let's talk now about details. So here's a cube. It's got the same shape on the top, the side, and the bottom. And let's talk about each of those faces and how it turned out. So on the bottom face, it's the smoothest. You get the best print surface right up against the print bed. But because of the way that a 3D printer works, it always squishes the bottom layer of plastic down so it sticks really well to the print bed. As a result, you usually get a little bit of mushrooming on this bottom edge. And as you can see, these details were squished in a little bit. It's not as wide as it should be. So you lose some detail. In fact, you almost lost most of the detail right in that part right there, simply because of the way it kind of smushed together. If I flip over to the top, I didn't have that problem. This shape is bigger. It looks right. The gap is about right. It wasn't smushed together. But this surface right here isn't quite as smooth. So if the smooth surface is the priority, go at the bottom. Put your details on the bottom. If it's not, put it on the top. And if nothing else, this could also be sanded down. Because remember, a curve or a detail like this should be printed, the curves should be printed horizontal, not vertical. And here's a reason why. Here is that same pattern printed on a vertical face. You can see the layer lines. You can see those steps. That curve didn't come through quite as well. In fact, this corner right here got rounded. You'll see a couple spots like right here where the layers drooped. And over here too. There was nothing supporting those layers. This detail didn't come out as sharp. Now you can go with a thinner layer height and this detail will come out better, but it's still not going to be nearly as sharp as that same detail on the top. So think about which details you need to print out the nicest, and always try to have them either facing up or down.